This video is for review quiz 3.2. Here we're trying to graph a polynomial function, and they kind of give us steps to doing that. The first one we're going to look at is the leading coefficient test to determine the graph's end behavior. And all we're doing here is looking at the degree term, which in this case is the x cubed, and the coefficient in front of it is 1. Now this is going to follow the same end line behavior, end graph behavior, as a regular x cubed function, which looks like this, which rises to the right and falls to the left. So it's going to go up on that side and fall on this side. So that's the end line behavior. It's going to fall to the left and rise to the right. The next part is to find the x-intercepts, and this is all about factoring. So the x-intercepts are when f of x equals 0. Of course, f of x equals x cubed minus 3x squared minus x plus 3. And this is a 4-term polynomial, so we can try factoring by grouping. Let's try looking at the first two terms. I can take out, take out an x squared. That gives me x minus 3. And from the next two terms, I can take out negative 1. It gives me x minus 3. So that gives me x, we'll do x minus 3 first, and then x squared minus 1. And x squared minus 1 is a difference of two squares, which means we can factor it further into x minus 1, x plus 1. So we have three zeros here. We have 3, 1, and negative 1. That's the first question here. We got 3, 1, negative 1. And the next portion it says is, does it cross the x-axis at that point, or does it turn around? And that's based all on the multiplicity. And that's really just about, so as we know our zeros here, we're looking at what's the power on these things. So what's the power here, here, and here? Nothing's written for all of them, which means we have 1. And the whether it crosses the x-axis or turns around bases on the power being even or odd. If it's even, it turns around. It looks like a normal quadratic function, which looks like this. It just touches the x-axis and then turns around. Or if it's an odd function, it'll actually cross, because the basic odd function is x cubed, and that I showed you already, looks like this, which crosses the x-axis. So if it's an odd multiplicity, like all of ours are, then we have a crossing the x-axis at that point. So all three of them do that, since they all have multiplicity 1. There are no intercepts where it touches and crosses. Now, if you were to factor something down and you were to get something like this, like 0 equals, let's say x minus 3, x plus 2, and then you get x plus 2 again, this is really the same thing as x minus 3, x plus 2 squared, and that's when the multiplicity changes. So really we have 3 factors, but we have only 2 zeros, and so that's when you have a higher multiplicity than just 1. Okay, find the y-intercept. This is quite simple to do. You just plug in 0 for x. We get 0 cubed minus 3 times 0 squared minus 0 plus 3. Of course, all of these go away to 0, and we get just 3. The y-intercept of a polynomial will normally be this last constant term. That's going to be 3. All right, determine whether the graph has symmetry, and that you do by plugging in negative x. So we plug in negative x cubed minus 3 times negative x squared minus negative x plus 3. And we're going to simplify. So negative x cubed, we can think of this like this. Negative x cubed equals negative x times negative x times negative x, which is really just the same thing as 2 of them canceling. We have a negative and then x cubed. So essentially what we're doing is we're taking the negative and we're moving it to the outside of the parenthesis group. So for this negative x cubed, we can write this as negative x cubed Then we have negative x squared. Well, negative x times negative x, it cancels the negative, so it actually goes away there. And we get negative 3 times x squared. Negative times negative x is plus x, and then we have plus 3. And what I can do here is I can divide out a negative. The reason why I'm doing that is because I see this first term here is a positive. And so I'm trying to figure out if there's a positive x cubed somewhere in this. So if I take out negative, I get x cubed plus 3x squared minus x minus 3. And so now I have my positive x cubed here in parentheses. The issue is that f of x equals x cubed minus 3x squared minus x plus 3. And the thing in parentheses, and this is what f of x equals. These two things, this and this, are nothing alike. There's no way to make them similar. I took out the negative x, or sorry, the negative to see if that would end up having the same signs and everything, but it doesn't, which means there is no relationship between f of x and f of negative x that I can write algebraically. Therefore, it has neither even nor odd symmetry. Okay, with these 3 pieces of information, or I should say 4 pieces of information, we can try graphing this thing. We have the zeros were 3, 1, and negative 1. They all cross. They don't stay there. We also have a y-intercept of 3. And we know that it should fall to the left and rise to the right. So let's take the graphing tool. Let's see. Let me write my zeros here again. We have 3, 1, and a negative 1, and we have a y-intercept at 3. Okay. Let's plot this thing. We got 3, 1, negative 1 is the first one. And then the y-intercept of 3. And then we have 1 and 3. And you can see that it falls to the left, rises to the right. There's no symmetry in this thing. So this looks about correct. Let's see if it likes it. And it does. Okay, let's move on to the next one. We have find the zeros of the polynomial function and give the multiplicity for each zero. Okay, so the zeros are easy because this is already factored. We have x plus 6. That means we have a 0 at negative 6. And x minus 3. That means we have a 0 at 3. And you'll notice that the x minus 3 has multiplicity 2. Okay, so to determine the multiplicities, we have there's 2, 3, or 1 0. Of course, we have 2 zeros. The smallest 0 is negative 6. That has only one multiplicity because it's just x plus 6. There's no power on that factor. The largest 0 is going to be 3, and that has a multiplicity of 2 because it's got a power of 2. Okay, determine the behavior of the function at each 0. We have, if it's multiplicity odd, so like 1, that's going to be, it crosses. If it's multiplicity even, so at 3, it's going to just briefly touch the x-axis and then turn around. So we have crosses at negative 6 of multiplicity 1, and then turns around at 3 because it has multiplicity 2. Check it. That's all correct. Move on. Okay, the intermediate value theorem says that if a function is negative and then positive, there must be a 0 between those two values because it has to cross the x-axis at some point, or if it's positive and then negative. So that's all we're trying to see here. So first off, we have to actually plug in 1 and 7 into our function. We have 2 times 1 cubed minus 3 times 1 minus 5. Gives us 2 times 1 cubed is just 2 minus 3 minus 5. That's going to be negative 6. All right, plug in 7. 2 times 7 cubed minus 3 times 7 minus 5. right? Yeah. All right, 7 cubed. This is going to be 343 times 2, 686, minus 3 times 7 is 21, minus 5. That's going to give us 665 minus 5, so 660. All right, so we have our two numbers. We have f of 1 is -6, f of 7 is 660. The first one's negative, the second one's positive, which means the function has to cross the x-axis at some point to reach those two values. That's because the function here, a polynomial function, is continuous. And we know there's a 0 between those two values, 1 and 7. So we're just trying to figure out which one of these is the correct one. F of 1 was negative, so that's less than 0, so that's negative. F of 7 was positive, so we have f of 1 is less than 0, which is -6 is less than 0. And f of 7 is greater than 0 at 660. The function has a real 0 between 1 and 7. And that's correct. Okay, for this last one, once again, we have this another looking at the polynomial and trying to figure out what does it look like. We have a number of zeros here. Looks like we have x equal to 0, +5, and -4. Those are our zeros. 0 has multiplicity, I'll say multiplicity equal to 2. 5 has multiplicity equal to 3. That's the power on x. I'm just looking here at the power. X squared means multiplicity 2. X minus 5 cubed means multiplicity 3. And of course, x plus 4 has multiplicity 1. Multiplicity equal to 1. So we'll just keep that in mind for later on. Now it says the first one, what's the leading coefficient test? So we have to figure out what's the highest power of x. And right here, this is all factored. This isn't expanded out into the normal way we see polynomials. However, we can find it quite easily by looking at just the powers of x. We have x squared, x minus 5 cubed, and x plus 4. So if we were to multiply this thing out, we would need to multiply everything by every other thing there. And to find the highest power of x, you always multiply the x's. So from this term, right, this is just obviously x squared, we have a power of 2 on the x. From this term, if we were to expand the x minus 5 cubed, you'd see that this would be x cubed, and then something else. There'd be a power of 2, a power of 1, and a power of 0. The highest power from this will be x cubed, because we have x to the power of 3 in it. You're going to end up getting an x cubed from that. And finally, from this last one, well, we just have x there, so the highest power there is 1. It's actually the same thing as the multiplicities. If you multiply all these together, you get 6. So that's what the highest power of x would be. And the leading coefficient, well, that would end up being in front of this whole thing. If it's factored like this form, you'd see a leading coefficient out in front of it. There is nothing there, so the leading coefficient is just +1. So we have the highest power of 6 and a +1. That means it's going to look like an even function, which the basic one is x squared. That looks like this. It's the highest power is +1, so that's the leading coefficient. So we're not flipping this across the y-axis. If it was -1, we would actually flip it, and it would look like this if it was -1. But that's not what we have. So we're looking at this, which of course rises to the left and right. Rises to the left and to the right. Hopefully that makes sense, how I was finding the highest power of x and then the leading coefficient. You have to have those two things to do the leading coefficient test. Okay, the x-intercepts, we already found those. That was 0, -5, or no, 5, and -4. Okay, crosses the x-axis at odd multiplicities, which would be 5 and -4. Those have 3 multiplicity and multiplicity of 1. And then it touches the x-axis and turns around at 0, since that has an even multiplicity. The y-intercept is just, this one's going to be quite simple. Plug 0 in for f of x. Well, we can actually really stop there because the first term is going to be x squared, which is 0 squared, times anything. It doesn't matter what it's multiplying, it's going to be 0. So this thing just becomes 0. Y-intercept is 0. Okay, finally we can look at symmetry. So same process as last time, plug in negative x. We get negative x squared, negative x minus 5 cubed, and then negative x plus 4. So we're going to do a similar thing as last time. Negative x squared, well, that negative will cancel. I can just take out a minus from the x minus 5, negative x minus 5, I should say, and take out a minus from the negative x plus 4. And what I can do is I can move this negative on the outside, and that negative is already there. So we get times negative x plus 5 cubed times negative x plus minus 4. And those negatives cancel. So what this gives us is x squared, x plus 5 cubed, and x minus 4. And our function, f of x, is x squared, x minus 5 cubed, x plus 4. And there's no way that those two things can be the same. The minus and the plus on the inside of those terms, or I should say factors, you can't cancel them out. You can't remove them. You can keep trying if you want. You can keep dividing out a negative, for instance. You can keep trying stuff, but you'll see that you'll never get the exact same thing. By doing this process where I'm taking out the negatives and trying to cancel them, if it would work, you'd end up seeing the negatives would come out, cancel, and then you'd get f of x. But in this case, we did not, so there is no symmetry. Okay, the last part is looking at the graphs and choosing which one's there. So we have a few things we know. We have 0, 5, and negative 4. So let me write it down. 0, 5, negative 4. This was odd multiplicity. This one had even multiplicity. And we had a y-intercept at, what was it? 0. So that's kind of what I'm going to be using to guide my thinking. We also know that's going to fall, what was it? It was rise to the left and to the right. Yeah, it's even. So right now we know rise to the left and right. We know it has to be A or C. That's for rise to the left or to the right. Now we're looking for now is the zeros. We have negative 4, 0, and 5. This one just crosses, so that's good. This one touches, which is good, that's even. This one crosses. We also have a y-intercept of 0. So A looks to be the answer. Let's check C here. We have negative 5 for a 0, and that is not a 0, so we can immediately throw that one out. And A has to be the correct answer. And it's correct.